going to be reviewing exponential growth and decay functions. So you're going to graph these growth and decay functions and use exponential models to solve real life problems. Again, Desmos is always available to you to help you with the graphing part of it. So if you remember, an exponential function is a function that's in the form of y equals a times b to the x. So an exponential function, the variable is the exponent. A cannot equal 0, and b has to be a positive real number. Exponential growth function, if you remember, that's when a is greater than 1 and b is also greater than 1. It's exponential growth, and it looks like something below that we'll see in a second. The growth factor is what you call b, so the base is your growth factor. And then asymptote is a line that your exponential function doesn't cross, meaning this is a horizontal line that works as a barrier that your line, you will never get a y value out with that particular value. So if you look down here, here's what an exponential growth function looks like. That you should remember this from Algebra 1. This is the parent function. Notice in this particular parent function, a equals 1. Now this value right here will always be true on the parent function. You will always get 0, 1. Why? Because anything to the 0 power is 1. And it will start really, really close to 0, and then it'll start to jump and grow. The situation, you might remember the story with the rice doubled every day. I'll post a little video about that in a second that shows exponential growth. The graph will always pass through the points 0, 1 and 1b, whatever b is. Again, why? Because b to the first power is always b. Domain of all exponential functions is always all real numbers, and the range depends on the asymptote. In this case, we'll never get a 0 out for a y value. We'll never get y equal to 0. Why? How do you raise something to an exponent and get out 0? You can't. An exponent is a repeated multiplication problem, and there's no way you can get out 0 unless you're multiplying 0 by 0 by 0 by 0 by 0. All right, looking at the next page. Then we also talked about this in Algebra 1, exponential decay. So if a growth function starts small and then jumps really high, a decay function, as you can see down here, starts high and then jumps pretty quickly down to almost nothing, and it approaches its asymptote. So an exponential decay function is where a is still greater than 1 and b is something between 0 and 1, aka a fraction. Must be greater than 0 and less than 1, because something else happens when a is negative. The decay factor then is the base. How do you know? Well, wasn't that the same thing as the growth factor? Yes. You know it's a decay factor when it's a decay function. It's a growth factor when it's a growth function. So it's still the base value. Again, here's your parent function. This is your most general form of function. When a equals 1, you can see your graph gets big, or starts big and then gets really, really small. Still crosses this 0, 1, and still has 1b in it. That's the same thing as before. Why? Because b to the 0 is 1 and b to the 1 is b, even if b is some kind of fraction or some number less than 1. And again, the range is still y equals 0 because this is the asymptote. You aren't able to get out a y value that's less than 0 until you shift your function up or down. Graphing, plot points. So here are some x values to plug into my graph. When I plug in -2, 2 to the -2, That equals 1 over 2 squared, which is 1/4, or 0.25, because some of you will just plug it into your calculators. 2 to the negative 1 means 1 over 2 to the first power, which is 1/2. 2 to the 0 power is 1. 2 to the first power, 2 squared, 2 cubed. So you can see with the output values that the y values start small and then all of a sudden they start jumping. And again, this is a good one to watch that video about the grains of sand that I will be posting. So sketching the graph here, the asymptote will be 0 because I'm not adding or subtracting anything, so it'll be 0. So -2, 1/4 would be about here. -1/2 would be here. Here's 0, 1, 1, 2. Notice this is that 1b. The base is 2, so 1, 2 is in my graph. And then 2, 4, and 3, 8 would be up here somewhere. So it starts close, and then it really starts to jump. So there's your exponential growth. And again, remember, 2 to the x can never equal 0, and 2 to the x can never be negative. The only way for this to become negative is if you have a value that you're multiplying it by that is negative. The base is positive, so your output values can't be negative. Okay, moving on to the next page, graphing the reciprocal of this. This is going to be a decay because this value is less than 1 but greater than 0. So this is a decay function. Here are some values to plug in and evaluate. 1/2 to the -3. The -3 means to put the base in the opposite place with a positive exponent. Put the base in the opposite place with a positive exponent. Put the base in the opposite place with a positive exponent. This is still going to be 1. This will be 1/2. And 1/2 squared. That means square the 1 and square the 2, so I get 1/4. When I graph this one, -3, 8. -2, 4, -1, 2, 0, 1, 1/2, 2/4. So it's a, oops, it doesn't cross the axis though. It's a mirror image of the other one. It's the reciprocal. Tell whether a function represents exponential growth or exponential decay, then graph the function. You can use Desmos for this. This one will be growth. Why? Because that number is bigger than 1. Quick hand sketch. 4 to the 0 power is 1. 4 to the first power is 4. So I could plot those on my graph. Here's 0, 1, 1, 1, 2, 3, 4. Here's 1, 4. I noted that it's growth, so it's going to start small and it's going to get big. So there's a quick sketch. This one is decay because 2/3 is less than 1. Again, quick sketch. I know it has to go through 0, 1, and I also know it has to go through 2/3 to the first power. So it's going to go 1, 2/3. Then it starts big and it gets small. This one is decay because the value is less than 1. So it will start big and get small. It will go through the 0.01 because it always does. And then 0.25 to the first power is 0.25. And this is growth. Again, because the value is bigger than 1. So it will go through 0, 1, and it will go through 1, 1.5.